Yeah, so I think he started there, or when he starts, we will also see the AV, Royston.
We will see, Amit. We will see the AV.
Yeah.
It will be on the screen. India Next Build with Speed, it will play over there.
Yeah.
Correct, right. Yeah.
India, a potential superpower of the world, houses the third largest built environment sector only after China and the United States. With its vast untapped potential, the key to delivering the desired growth is clearly about embracing change, about unlocking new opportunities with speed. Speed, using design, technology and innovation as levers to transform our nation's skyline. The need to build, and build fast, resonates in every sector today. However, it is the housing sector where pace is critical. A thriving housing sector is the lifeline of any robust infrastructure, and the pandemic has established the importance of a home in uncertain times like never before. Today, the need to address the housing deficit in our country has become non-negotiable. India Next, an initiative to engage the architecture and engineering fraternity to play a pivotal role in realizing a developed India. Our past four editions have addressed critical contextual issues facing the nation, taking cognizance of the need to build and build homes fast. The theme for the India Next 2021 is Build with Speed. We look forward to inventive design ideas to fuel speed in housing, both in the urban and rural sector. Given this being the most urgent task of the nation, Build with Speed is now beyond just a competition. This is your chance, architects and engineers, a chance to be a catalyst, to bring momentum to our nation's rapid ambition to give every Indian the house that they deserve. India Next, build with speed.
Hi, good evening, everybody. Just a small check to ensure if my audio is clear. I request my panelists just to give me a thumbs up if they can hear me clearly. Thank you very much. So, a very good evening and a very warm welcome once again to all our guests, architects, engineers, students, and key partners who have joined us today online for our third webinar series on the Ultratech India Next initiative for 2021, Build with Speed. Our past two webinar series have not only helped in delivering fresh content in the building and construction space, but has largely helped in educating, demonstrating, instructing, and providing information of interest to our competition participants, our fraternity, and our community at large. We are overwhelmed that the community has responded that these webinars have indeed been a source of guidance and inspiration to each one of them and help leverage the thought process for design thinking and innovation. Do keep writing and sharing your feedback, which will not only help us improve and enhance our content and information through these knowledge series. As put across by our earlier speaker, Dr. Anil Swane, the competition theme, Build with Speed, is an anchor which will connect to all our dimensions within the competition, that is cost, quality, people, digital technology, etc. And hence, the three words, Build with Speed, are a very powerful message sent as a calling for architects and engineers to embrace this holistic view and make something that will meet all those dimensions. As India's #1 cement, Ultratech will always be at the forefront of such initiatives to enable our community in furthering their perspective and continuously striving to be the change leader. With this thought as a backdrop, it's now time to invite my very first guest for this event, Mr. S.V. Patil. Mr. Patil has spent various positions in cement marketing for the last 30 years before moving to his current assignment as All India in charge of RMC division and key accounts. During his tenure as zonal head marketing for South and Maharashtra, he steered the cement business to a higher trajectory in those markets amidst hectic competition and carved a niche for Ultratech cement brands and allied products. He has a passion for adopting new technologies for effective implementation in affordable housing, wide topping of roads by using sustainable material along with cement and concrete to build durable and sustainable infrastructure at an economical cost. He is a firm believer that technology is a powerful driver of both the evolution and proliferation of innovations. Please put your hands together for Mr. S.V. Patil. Sir.
Thank you, Royston. First of all, I think build with speed. What a relevant topic for the today's context. I think the seminar is very apt for looking at the challenges and the entire speed that we are looking for, and more so in the sphere of construction, where unlike in the past, the construction technologies are evolving very rapidly, looking into the need of the construction industry, both in infrastructure, urban infrastructure, residential, commercial. And who could be a better person than Mr. Amit Berde to deliver this webinar on precast technology, which is one of the emerging technologies to improve the speed and quality of construction everywhere. Amit joined India's leading construction company, Larsen & Toubro Limited, as part of a precast initiative of residential SBB in 2012. Over a decade of precast experience in the United States with a leading precast manufacturer, is currently heading the precast initiative for building and factories and actively involved in developing and promoting precast technology adoption in residential and building sectors. Mr. Amit is known for his expertise in variety of residential, commercial, industrial precast concrete buildings. He has designed and managed several precast concrete projects such as data centers, office buildings, schools, warehouses, industrial plants, stadiums, parking structures. Currently, he is actively involved in the construction of very prestigious SIDCO PMAY housing project in Navi Mumbai, the largest order of residential building group. With penchant for modern technology, Mr. Amit has spent extensive time in exploring state-of-the-art construction technology for rapid and cost-effective construction during a stint in India that brings a unique mix of overseas precast construction expertise complemented with a thorough understanding of Indian construction industry and current requirements and the capabilities. Mr. Amit graduated with honors from the Government College of Engineering, Pune, later pursued his higher studies in the prestigious Purdue University of USA to complete his master's in civil engineering. He recently has also completed an executive MBA from Indian School of Business, Hyderabad. He is a member of ICI India, is a licensed professional structural engineer in both US and in India in Navi Mumbai, and also a member of certified professional for USGBC, that is the US Green Building Council, and the lead certified professional. Who could be better than Amit to present this webinar on precast structure? I don't want to come in between his presentation and you people presenting to you Amit Bhatt. Over to you, Amit.
All right. Yeah. Good evening, everyone. I hope everyone can hear me, and then my screen is visible now. Mr. Patil, you can see it.
Yes, you're visible. Yes, you're visible and audible, and everything is clear.
Everything is fine.
All right. So yeah, thank you very much for the nice introduction. You're too kind. I guess before we begin, thank you very much to Ultratech and the India Next event for this opportunity. More than the presentation, for the opportunity of being one of the judges, because I'm like really looking forward to going through these entries and looking at things that what we are planning to build India probably for the next 15-20 years. The theme of that whole competition is speed, and this is what I think we have been chasing, that speed for last several years in construction. Many places we have succeeded, many places we are still working on it. So in line with the theme of the competition, what I am planning to do the today's talk is one, it will be revolving around that speed and what we are doing for the speed, how we are catering to that speed. Second, in line with again the competition, this will be focused more on the residential and more on the mass housing projects that what we have been dabbling on. And very lastly, it will go on how we are catering to this speed, or actually the India's demand in terms of technology and then the digitalization. Those are the key themes of this presentation. I'm looking at somewhere around 50 minutes, and then we'll have question answers depending on how the interaction go. What you see on the screen is pretty much what we have been doing for last 8-9 years here in India, L&T Construction, especially the residential buildings group, right? Most of these precast initiative, what we call it, it comes where the management feels that there is a significant need, and then management decides to support that new initiative, and it is treated as an initiative until it becomes its own business over the years. So precast is not new to L&T, right? We didn't start precast in 2012. We start precast for residential in 2012, and then we named that as an initiative, specific focus on mass housing projects. That's the idea behind it. So just a little bit about the company. Of course, all the numbers are there. I'm not going to spend time on that, but what we take pride in it is being a professionally managed company and one of the most innovative companies, right? We call it it's Imagineering, not just the engineering. There are various vertical amongst the company. Again, I specifically come from the buildings and factories group right here, and that's where the focus is on buildings, and again more on residential construction. Not a lot of people actually know L&T in residential space, right? Usually it is all infra and huge projects, but we do a lot of residential work. Usually in line with the company's name, the largest and the tallest L&T, what we call it. So a lot of projects that you see, more than 250, 300 meters that are going in Mumbai in the residential space. Mass housing, if you see the project on your left, there are 6 tall buildings, right? It's like a city on its own. That's the kind of projects we're looking at. Of course, on the commercial space, public space, we have Statue of Unity, one of the recent projects. The T2 airport was built in that commercial space. If we come to precast specific now, the Narendra Modi Stadium at Motera, that was total precast, one of the very recent buildings in the precast space. And of course, now we are building the high-speed railway, right? This is all going in precast. What you see in the picture is one of the most indigenous and unique system where we are lifting 40-meter long girders for the high-speed railway. The entire assembly, what you see, it's automatically controlled between those 4 columns that you see with the wheels, and all built in India. None of that was coming from outside. In the precast space itself, what I'm going to do, I'll just go through the quickly one of the recent project portfolios in commercial and residential space, and then we'll be focusing more on the residential space after that. So this, if you see one of the projects, the high-rise projects in Kolkata, that was done in 2012 to 14 time frame. And the structure is of course cast in place, but the facade that you see was done in precast. And the architect wanted that wave, they wanted the vision of the wave, which is a nightmare if you want to do that in conventional system, shifting your formworks and coordinating that. So we took that quick call where only the facade was built using that wave pattern. This is a Cognizant Technology building in Pune. This is one of the first buildings that we did in precast around 2011-12 time frame, right? Commercial building, total precast, columns and beams, and then hollow core, usually 8 to 10 meter grids. Usually that one hollow core system, lot of questions come on MEP that it needs coordination and all. If you put that time, if you do that coordination well, during execution time, we did not have a single complaint or single query or questions from the MEP contractor on this job. This was one of the first jobs. Then this is a parking structure. If you are from Mumbai, when you go to your domestic terminal, you will see this on the left-hand side. If you see from outside, you don't know if it's precast or conventional. That's the idea. That's how we put a lot of efforts in bringing the technology where the end user should not feel any difference just because we have chosen a different technology. So this again was total precast, beams, columns, and hollow core system, same as that CTS building that I showed. This is in Bangalore for the Wipro, where you see all these bands. They were not initially conceptualized in precast, but once we started building, because that building inset and all, it was becoming very challenging to do it in conventional systems. So only those elements were quickly converted to precast. This again a project in Mumbai, the IKEA warehouse in Navi Mumbai. If you see on this picture, hollow core slabs we have done before, but 2 unique things. It's a hybrid structure where you see steel frame, and then the floors were put quickly using the hollow core system. And it's probably somewhat difficult to gauge the size, but this is one of the deepest hollow core that has been used in India in building sector. It's 400 deep hollow core element, and the span is about 16 meter. All right. And the load is about warehouse load of about 750 kg per square meter. So largest load and largest span, and that hollow core span was used. The biggest advantage we got there, if you see it, steel structure is ready, slab is put, no shoring from below, and then just the concreting done to finish that floor. Almost about 50% improvement in productivity. If you ever visit that store, and if you're walking on that showroom floor where all the furniture, all the rooms are set up, you are walking on those hollow core slabs. This is one of the jobs now ongoing in Vizag, where we are doing a total precast substation for a refinery job, right? So that substation is like a heart of that refinery. If you see the refinery project, it is anywhere between 15,000 to 18,000 crore. The substation is 35-40 crore. structure, but without that the entire refinery cannot survive or cannot operate also. So we took that call to make it into precast, again that speed where they can start operating for the refinery. This is a office building in Hyderabad. When the building started, the architect had the vision of these C-shaped panels and bands, and this was conceived in block work. After starting the building, we took that call saying it's just too much block work to do plaster, and also all these bands and the exterior facade was converted into precast system. Why I'm showing this is even for your competition now, this is what the theme we are saying, speed. We are trying to, wherever that speed demand is, we are trying to make sure that one, of course, we are going to come to that in discussions later, but move it to factory, move it offsite, make it industrialized, and reduce site work as much as possible. So all these key projects, at the heart of it, you're going to feel these 3-4 things, which are the need. I'm not doing precast just to push precast, right? This is coming from an inherent need of the company or the projects that we do. Now, this is a new proposal. It's not a working project, but what we call it is ultra rapid. Same building as your Hyderabad building in Mumbai, but now this is a 27-story tall building, and you have all this block work wall. It is right next to Powai Lake, so you get a lot of rains and everything. So doing block work is going to be a challenge. Even if you do really well block work, really well plaster, there's just too many vulnerabilities to get that leakage or get the work done faster too. So what we said is we will do precast panels, and we proposed welded connections. So usually my precast panel will take 2-3 days to finish, right? You erect the panel, do the jointing, do wet concreting. Here with the welded connections, because I have steel structure, the mock-up panel itself was attached to the structure in just under 30 minutes, right? That's the time speed, that's the ultra rapid what we are looking at. Erected, connections welded, and ready for the sealant and finishing activity. So that's the crux where we are trying to look at these precast options. Now with that, coming back to residential, I think from this point onward, pretty much everything will be discussed around residential, and more for the mass housing scope. So mass housing is not new to us. Again, a lot of projects since last 15-20 years, various projects. These are all conventional system projects, but why I wanted to put it is that's the experience under our belt to know what the residential client wants, to know what the residential construction beast is, right? Commercial is a very different construction system. Commercial is a very different place where you are only dealing with one client. Here you have one flat, several flats. Each flat has probably 4 or 5 people living in it, if not 4, at least 3. So those many number of clients, you are looking at that. Government projects, private projects, bunch of experience under our belt, right? Looking at various things, high rise, mid rise, 20 buildings to even 100 buildings. So all this experience, and among all these years, what we have learned, and probably this will be very connecting to the competition also when you are doing your proposals and all. What does your end user want, right? I want to build faster. End user doesn't care, right, if I build faster or not. I am a contractor. Maybe my developer or client would want it faster. The end user cares about these 4 things. We do a lot of surveys. We interact with the end users. We before possession, after possession, and these are the 4 things of the life cycle that usually, let's assume a mass housing project, a government project. So this is what the flat or the accommodation is their aspiration, right? There is a social connect, there is a social pride in that. So that's what they want. They want to have that pride. It's of course a long-term investment. They want it to be there. 50 years, why 50 years? We get the question of 80 years, 100 years, why not? So they want that to be there. They want something low maintenance. They want something that electricity consumption will be less. There won't be any maintenance issues. They want something that is acceptable by everybody, where they, if need comes, they should be able to sell it off easily and get that return, right? Now I said at the beginning of this slide that, okay, assume a government housing project, a mass housing project, but if you see these 4 points, this is pretty much everybody wants. I want the same thing from my house. You think about it, you also want the same thing about the house. The price tickets may vary, but at the end you want all these 4 things from your home, and that's the basic requirement or need of your residential industry. So with that aspect, when we start looking at it, and again, I wanted to connect this with your competition, that this is a line we picked up a while ago, but it has kind of set in our heart. It pretty much goes with what we do day in, day out, right? Your building is not going to come on its own, right? It's not the age where वो मेसन को दे दो, वो बीम कॉलम 4 बार तो डालना है, उसमें क्या है, बिल्डिंग ही है 6 स्टोरी का. That thing has gone far away. Even if a 6-story building, now we are doing the value engineering, there is a value creation behind it. You have to look at all aspects, and you have to make sure that it is addressed in terms of your cost, your construction speed, what your end user wants, what are the building bylaws, are you making sure everything is done, is the structural integrity done, checked, design is checked, have you validated. So if you are looking at any new technology, all these aspects will then funnel through to get you what you want. Then it will be automatically accepted by your client, it will be automatically accepted by your end user. And how you do it is not just one entity, right? That's what I'm saying, that it's not going to come that I do the structural design and your building is ready. You have to start from your foundation, you have to start from your services, the coordination, where each pipe is going. This is where that beam is coming into picture, saying my plinth beam levels are those checks where my rainwater pipe is not going to hit it. These are minute things where over the years this was done in terms of, for a lack of better word, jugaad kuch to kar lenge and then we'll see. But we are not there, right? We want a functional design, we want everything right on the paper. So with all that, now I come to the broad contents of this presentation today. Maybe next probably half an hour to 35 minutes, this is what we'll be discussing. So one is why we are doing precast, how the industry has evolved. Then the precast technology design philosophy, what we are doing in residential projects. I'm going to take up some case studies, and while I explain the case studies, we will go over the production process, the construction process, quality control. Lastly, maybe last 10 minutes, I'll spend an hour that ongoing project, right? It's one of the largest project for the residential BU. It's more than 5,000 crore worth that we took it in precast for the Circo housing project. So we'll spend over it. We are about a year into the project, so we're still building, we're still doing. So I don't want to spend a lot of time there, but at least to give you a flavor, maybe next couple of months we can get into a lot more details. And then how we have adopted digitalization, that I mentioned in the start as well, saying this is one of how the technology is adopted and how we are using digitalization to make it even more effective, to make it even more efficient. And lastly, maybe 2 minutes, I'm just going to say way forward where this precast technology could go, or what is the outside world doing, whether we'll be able to match it, do we really need it, why we need it, and how we go about it, right? So this is what this screen pretty much tells, how the technology has evolved, right? So we have been doing conventional formwork for long. Like I said, India has seen one of the latest and greatest technologies everywhere in all industries. Maybe somehow construction has lacked some, but the last 30-40 years we started conventional. Then we experimented this tunnel formwork system in the 90s. This is by far the fastest system as far as speed is concerned. If you want to check it in terms of the cycle time, even in today's age, if you want to look at that core and shell speed, there is nothing that beats the tunnel formwork. They have their own challenges to finish the building, but as far as the core speed is there. Then of course in 2002 we ventured into aluminum formwork. This is one of the most popular now system option that L&T has adopted. Maybe when the market was at peak in 2016 and 17, we were doing more than 400 towers in country at the same time, and 95% of those towers are being used in aluminum formwork system for residential. And at that time, still management felt that aluminum is not going to be enough for what is to come, right? In 2010, where we ventured into precast, the PMAY or the housing for all came in 2014. But this was the conscious call was taken in anticipation of such projects, saying that housing need is going to come and the aluminum formwork system is not going to be enough. And that's where we started this precast initiative. So with that, now before going further, I think I have a quick poll. I think Deepal, if you can run that, maybe time whatever you want to do for a minute, and then we'll get into the presentation again, right? Let me know when the poll is done, then I'll start again. I think I would encourage everybody just to go through it, so that once we know the pulse of the audience, you would also, I think, should be able to think on those questions while I'm explaining these things. That's the idea, more than the information that is coming to me. I would want you to think, saying, okay, these are the things, this is what maybe your contractor is asking, what is my answer? And then we'll see how we are explaining, or how we are going through the presentation.
Amit, we'll close at 50%. Should we close it at 50%?
Sure thing, that's more than enough. All right, I think the results I'll anyway look at later. I don't need those now. So Deepal, I think again, everybody can now see the screen and hear me.
Should I launch the second poll now or after some time?
No, the second poll will come later at the end of it. So we'll start.
Yes.
All right. So I think, yeah, welcome back everybody. With that poll now, next what we are looking at is why we need precast, right? We started precast, and again I keep repeating that I am not in precast business. L&T is not in precast business. This precast has evolved over our need. So if I have to put the data behind it, on your screen you see what we did is we took up the one project, same area, same location, two plots, maybe adjacent within a kilometer or two distance, and one was being done in cast in place, the other is being done in precast. And what we did is we tracked the time required for doing cast in place construction, time required to doing precast construction for the first 100 slabs, and that was tracked in terms of 25 slabs, then how much time it took for the 50 slabs, 75 and 100, and likewise. If you see this data firsthand, you're going to see that our CIP is doing much better than why you would want precast, right? This is where your technology comes into picture, right? What resources you're putting it, at what cost you're doing it, that's what matters, not just the number of days or the screen. So when I start looking at conventional, this is using aluminum formwork, you have to look at how many sets are deployed, right? That's my key resource. Whatever you see, if you start looking at these asset turnover ratios and all, at what assets or at what investment you are performing. So in aluminum system is the aluminum formwork set. In precast system, it's the crane. That's my key resource, key bottleneck at the site. So how many cranes I have put it, and per crane what am I doing out of that. If you start looking that in terms of resources put and then the cycle time, days per slab, you will quickly start seeing that even if this is quicker, this was done at many more sets, right? There was almost 20 plus sets put in. So per set I still took 25 days to build one floor in precast, and in cast in place it took 38 days to build one floor. So it's obvious over the system that you are seeing that the precast is doing better in terms of your resources. If I need even more speed, because this is designed to what is planned, what the client wants, I can just put another crane and get more speed out of it. Putting another formwork set, it has its own issues. Right? The second thing is, if you look at how we improve things, right? This is all, the two projects were not going at the same time. There is some delay between it, but usually you take little more time when your project warms up, and then you improve your speed. So this improved, this increased again for the COVID second wave, and then it kind of maintained. If you see precast, this has quickly built up and once it build up, it has sustained that cycle time, right? That's what I wanted to drive through this. The other, if I do again the same project, whatever we estimate usually, if you look at aluminum formwork, we want less people at site, right? We want less resources so that my risk is lesser, right? One of the biggest risk in construction today, especially residential, is having your workforce at site. If you have heard, everybody, when COVID waves hit, what biggest thing was getting people back, right? That everybody, even media, was talking about it. So if I have less people to do that work, same work, my risks are less, right? The challenges are less. If you look at that in terms of that entire activity, what is going in aluminum formwork, per cubic meter of concrete, I need about 5.5 man days. So assume I need 5 people there. For the same thing in precast, which is conventional precast and automatic precast. So this is what we are doing now. We can even go to fully automatic, what usually the global industry does, and it will improve even further. But I have kept it for the where India is right now, what we are doing at best. I am looking at this 2.5 man days, so it's about half. But that's not the real story. Out of these 2.5 man days, I need about 1 for production and 1.5 only at site. So if you want to compare now site activities and precast and conventional construction, I have about 70% reduction of site activities or site requirement of people. And this is where I'm covering my risk. I don't have to worry as much about having the workforce at site. Workforce at factory is a very different ball game, right? We have a very higher retention ratio at factory because they're working in a much controlled environment, at ground level, covered shed. I don't have that worry of not having people, right? Whatever, who is there, they always stay. So in a nutshell, what we are doing on other line, if you see at site, conventional construction, if you look at the activities, what these 5 people or 3 people are doing, you have to build the formwork, put the reinforcement, do concreting, block work, plastering, POP, painting. Since we took up that aluminum formwork system itself, we have completely avoided the work, right? This is the work where you need maximum workforce in place, the block work, plastering, and doing that leveling and everything. So what we are doing, we are instead doing this shear wall system using aluminum. Forget precast for now. Even why aluminum became popular, because these activities were removed. I'm going to talk about that a little more later. Now what we are doing in precast is still, this takes a lot of time. That 5.5 people per cubic meter, what we are talking about, that we are taking it off site and doing everything in the factory, finish it in factory, bring it and install. That's the idea. And where we will adopt it is projects like this. This is our AP housing project, 1 lakh houses straight. This is what they wanted, same buildings, and this is what that basically housing for our demand is. We keep talking about 12 crore houses, this, that, everywhere, but if you look at single project in nearby 3-4 plots, they had this demand of building 1 lakh houses which are similar, ground plus 4-story tall buildings, and you cater to that. Now how do we solve that challenge? We just look outside, right? We look at our neighbors. We are not the first one to go through this challenge and do the social housing problem or the mass housing problem. Singapore has done it, Shanghai has done it, Tokyo has done it, Hong Kong has done it. All these countries have done it. And this is just our neighbors, which has similar setup, similar situations. How long they took it? They have taken about 20-25 years time frame to do that. And we are looking at doing it in 7, 10, maybe 15 years now, but at a drastically smaller time period. This is where that speed is coming into picture. How the speed will come is using technology. Have we not adopted technology? In all other construction aspects, we have adopted technology, right? I am from Mumbai. If you are from Mumbai, you stand in Mumbai today. We are building the metro all over Mumbai. We are building the coastal road. We are building the Trans Harbour link that connects Navi Mumbai to Mumbai. We are building the high-speed railway. One of the latest and greatest projects using the greatest technologies globally are being operated in Mumbai at single time. They cannot get better than that. But still, if you come to residential construction, we are lagging, right? We have to do something, and this is what we are doing. How these other guys, what our neighbors I mentioned are doing, is the only answer that comes for all these countries is industrialization, mechanization, right? Is there anybody who's now stitching our own shirts? No, we are not stitching our own shirts. We are not stitching our own shoes. There are factory made products in that range, and we are very well adapted to do that. This is where the residential construction has to go. There are set standards, set standard units, especially for mass housing where we are looking at large volumes, at whatever requirement, functional requirement, and you put it in the factory, make it like a car, make it like a shirt, and then construct. So that is one of the biggest driving point, if nothing else about technology, if you want to take it home today, is this industrialization and mechanization. That's how we can get that speed. That's how we can get that answer to our solution. The second thing is less activity at site, right? This, if you see picture, both are similar buildings, both are RCC buildings. One is beam column frame and the other is RC shear wall system. One is only 50% done when you finish that slab cycle, and that's how the slab cycles are measured, right? If this is done, your developer says, okay, slab is done, now give me my money, but the building is only done 50%, and that's the industry norm. But block by block, you have to set it up, do plaster. We don't have people anymore to do this work, right? We keep talking on various forum, we keep discussing with various people, and one thing that was discussed maybe 3-4 years ago that has stuck with me a lot is, if you see 2006 in India, your mason's son did not want to be mason. He wanted to do something else, maybe do technology, do other job, but not construction. In 2022 now, even the mason doesn't want his son to be mason. That's where we are, and that's great. India is shining, we are going forward, the society is improving, our quality of standard is improving, quality of life is improving. But for me, construction, I don't have people to do the work that we had earlier, and that's where we are leaning towards this technology. So that's the second point I would like you to take home, is we don't have skilled workforce anymore. Whoever is there, they don't want to be in construction, so very limited people are there. And the third and last is the maintenance, what your people or end user want. And one of the biggest maintenance item in residential construction today is your plaster, internal or external plaster. Plaster was never meant to be a long lasting product. It cannot be. It's a sand cement mortar mixture. It absorbs water. Over the time it cracks. Over the time the paint fades because of this water absorption issues. So what we are doing today, the technologies that we are evolving, evaluating, or trying to adopt, not just precast, any technology, we are avoiding plaster. That call was taken in 2002 timeframe, right? When aluminum formwork became popular, is for this very reason. Especially in high-rise construction, I don't want to go outside, put that scaffolding and finish the building. I will pour concrete, even if it's slightly more it cost. The net tangible benefits are much higher compared to the upfront cost. And this is one example. This is our building. This is a precast building, but the lower floor was done in cast in place because it's a non-typical floor, and this was done in brick wall and plaster. This big, and then the above building is in precast RC concrete. This picture is taken about 6 months ago. After 7 years, that building has been standing, and this fall started right after a year and a half, and that's how that water absorbs. Then the moss, same maintenance, same treat, whatever, this is same, but the above portion, you see there is no cracks, nothing, whatever shadows, but this is what the paint falls fade. This is why we are doing this aluminum formwork system or the precast system. So some of the landmark jobs now getting into the case studies, this is one, that same job actually, Pragati Towers in Mumbai, ground plus 23-story tall building, about 70-meter tall. Everything after the first floor, what you see in the picture is done in precast system, factory made, including your spandrels, the walls, the lift shafts, the precast stairs, the whole 9 yards. Right, this was our one of the flagship projects. That picture you saw 3 buildings, we later added 3 more. So about 2000 flats were built in about 3 years time frame. It of course won several awards. Yeah, thank you. Several awards, and building has been standing and occupied for last 8 years now. The second project, which is what I'm going to discuss little more in terms of the case study, is our Providence Sunworth project in Bangalore that we started in 2014. Again, mass housing. This was for a private builder. It's not a government project. About 66 towers, 5,000 plus units, all G plus 12 or G plus 14 towers. Total precast system. What you see in picture is all precast. Somewhere in the middle of the job, we got this certificate extemporary from the client, so it is really close to our heart. When we finished one G plus 12-story building in flat 3 months. 3 months that superstructure was built from that first level to your terrace. That is the strength of your technology, why you would want to do. Same footprint building in conventional, even aluminum formwork, which is considered the fastest now, it will take at least 7 to 8 months to do that. Right? These are some of the finished project photos. Again, if you see that engineering, whatever I was meaning, the coordination or detailing, a lot of it goes so that the end product doesn't look any different for your end user. Like these buildings from outside are going to look extremely similar to what your end user is used to seeing. The same chajjas, the balconies, the sunshades, the paint, the joint, architectural treatment. Finished buildings don't look any different, right? So with that, now we're talking about the industry shift, where the future would go, or what we perceive it would be. If you again look at that overall residential industry, this look at from your low-rise construction to mid-rise to high-rise, the industry is shifting towards using hybrid technology. I don't think there will be one single technology that will be like the go-to choice like aluminum form. We are looking at something hybrid where we take advantage of multiple systems. We are looking at this prefab philosophy, right? You don't work at site, move everything off site, do as much as possible work at factory. In those two concepts, now if you see your overall industry, this is what we are doing today. If it's a low rise, let's say G+4, G+12 system, we are doing aluminum formwork that works really well. We will move to 3D printing. We are already in very advanced stages of doing 3D printing. This is actually a 2-story fully 3D printing building built by L&T in our Kanchipuram factory. It's standing there being finished. Right? No other thing has been used except walls in 3D printing and slabs in precast. So that will go for the low-rise system. For your mid-rise system, again, there is precast or aluminum formwork options are there. We are doing this today. Where it will go is your PPVC or volumetric construction, again, finished at factory. For your very high-rise buildings, what we are using today is your slip form comb and aluminum formwork combination. Where we think we'll go is slip form for the core works really well, but finishing in aluminum is taking its own time. So we may go towards your finished precast cladding panels, facade system attached to the buildings faster. So this is the entire industry shift what we anticipate will come over the years. So we talked about that. We'll get into design. I'm not going to spend a lot of time in design. It more works on the structural detailing and all, but if you have questions, please feel free to get into. But overall structural system wise, if you look at that, what we have is a large panel system. What we usually do is for the residential construction, we have a frame system that is usually used for the commercial bays of usually 8 to 10 bays. This residential is usually 3x4, 3x5 type system. What we are doing in general is, let's look at residential construction now. I'm going to take the floor plan what we have, right? We are not there where the floor plans are being built for precast. If you see the outside world, and a lot of architects here will be here. So going forward, I hope the design industry shifts towards that they know the technology they are going to build before they start the drawing board, right? And the floor plans are built suitable for the technology. Here in India, I think we may or may not go there, but our again end user has requirements. We need in and out layouts. We don't have boxy buildings. I don't see residential buildings being boxy. So what we have done is worked around saying, okay, my floor plans are going to be in and out. They are going to have complicated shapes. I will work with those shapes and try to make as much as possible 2D panels and then convert it into my precast systems. That is the work that I have to do to make sure you get that performance out of it. Once you do that, all we are doing is layout is ready, make these elements in the factory, put it on site, erect it by crane. It is not rocket science, trust me. How we do it, structural system, like I said, load bearing shear wall system, that's the crux of. There are various structural advantages to it, but if you look at this floor plan here, this is how we were doing buildings 20 years ago, where there are some walls and then your beams and columns. What we are doing is we are trying to see if we can do all walls. some of those walls are still my shear walls, balance are still my gravity walls. It is equivalent to your beam column system, right? Not all walls are not shear walls in the system. Now once we pass this, now in precast what we are doing, right? So I am doing the precast philosophy is the next step of your aluminum formwork system, nothing else. What exact same system, same building, only thing is I split the panels and make it in factory. How do we connect it? We are using this emulative approach, right? We can't get into too many details, but you just focus on the word emulative. What that means is if you use this emulative detailing, your precast building is going to behave equivalent to your conventional building, that is aluminum formwork. This is from American Concrete Institute. They have a specific standards for emulative detailing. They will tell you exactly what to do. If you do that kind of detailing, the wet construction connections, you get equivalent performance. There is a Precast Concrete Institute again in US. They take even a further step. They said that if you do this emulative detailing, regardless of seismic region, you will get performance equivalent to that cast in place system. And this is what we are doing. What is not emulative? It's welded connections, bolted connections. We are probably a couple of years away in India to adopt those. There are various reasons. But if you want to see that emulative performance, we also were getting that question a lot. So what we did is we ran a full-scale test program in 2016 timeframe, saying this is how I'm going to do emulative detailing, and I'm going to validate it if it gives me equivalent performance. Right? That word equivalent is important. I don't want better performance. I don't want superior performance, because all our design codes are currently built around RCC system. So I just want to make sure that I build one specimen in conventional system. These are my two shear walls, foundation if you want to imagine, and a slab on top of it. This is a full 3-meter high tall wall, right? And we are validating the seismic performance. So this is done in SERC Chennai lab. This was one of the very few labs at that time which has this seismic actuator, which kind of pushes the building and pulls it in a controlled manner, so we can study it in detail and see how the system is performing. So this cast in place specimen was prepared, and then the precast specimen was prepared using the joints, right? Excuse me. Again, idea is, like I said, we want to see if they're performing similar. We don't care really at what level. So these precast joints were emulated, and then you look at your force versus displacement curves, right? That's in engineering term, that's how my toughness is going to be calculated. The area under the curve is going to be the your E values, or if you are going to be your R values, equivalent performance, or the ductility, what we call it, looking for it. So again, this in precast and conventional has to behave similar, then we get equivalent performance. And usually I get that saying, okay, see, your equivalent performance is not there, cast in place wall is so higher. But if you really look at that, SW1 is my cast in place wall. This is that CIP construction specimen, and these two are my precast specimen, and these are behaving similar. This is what we want. If you calculate that area under that curve, you are going to get similar performance. This is actually one of the precast connection that works better than your lab connection. That's how you see the higher values. All these walls were designed for same design capacity, right? So this is the grouted couplers what we are using now. I think after 6-7 years of following up and making it available in India. But these are confined couplers, high strength grout. They use M100 grout, and that's how you get slightly better performance out of that, right? Now at that time we didn't have any testing in India, so we went to Hong Kong and got this tested for the cyclic performance. That's where that seismic detailing is important. So if you want to look at it in one summary, this is reverse cyclic test. So if this is your 0, it is pulling and then pushing to 50%, 95% of tension to 50% compression. So you get that cyclic behavior. They have 20 cycles, then they pull it to twice the yield and then do 4 cycles. They pull it to 5 times yield and do 4 cycles, and then they pull it to failure. And after that, the test says that your failure has to be in steel. That's where you get the ductility, and not in the brittle portion where the grouted connection is being done. So this is one of the key validation how you get ductility in your precast systems, right? All these connections, if you see beautiful yielded curves, this is where your steel is yielding. It's giving you that indication, whatever you learn in your schools, right? That you have got the failure indication warning. It cannot be a sudden failure. So this yields, give you enough warning, and that fails. The grout does not fail, so your system is ductile. Same way we have done other systems where now we check the slab and wall full scale testing again, where we looked at the load path, where your diaphragm action is working or not. Then we looked at the vertical connections and saw how the performance is going. So that entire connections portfolio is there, validated. Once that is done, that emulative detailing, you are going to get similar performance because your concrete elements are much better. Right? I am using at least M50 grade concrete because of my early removing strength and all. So that element is going to be much superior than conventional system, and your joints are validated. So on that lines, we have now several approvals, everything in place from all leading institute. IIT Madras is usually our peer review agency for all precast projects. You go to IIT Bombay, we have that certification. And including the government agency BMTPC, which has certified it for the government projects. So that's quickly the design philosophy and how we have evaluated the technology, how we have made sure that all the requirements are with us. All these test programs were not really needed, right? This has been done outside. Of course, we did slightly different, the reverse cyclic way and all that is not even done outside. But we wanted that validation. We wanted to make sure that tomorrow nothing will get questioned and that entire portfolio is ready. That gave the confidence to go and tender for a 5,000 crore project, saying the technology, right? You cannot go for that large project on a whim. The management also would not allow that. So these are the requirements to go through that. Right? Now, how the technology is done, build, construction, maybe 10 minutes, and then by, I think, Deepal, I think by 8:10 or so, I should be wrapping it up. So this is that same project, Provident Bangalore, 66 towers that I said, 2 phases were completed. Very typical flats, about 800 carpet, 1080 carpet, whatever layouts that the client already had. We did not change anything in that layouts. Finished project, some more pictures if you want to go through it. But everywhere you see detailing, the focus is making sure that you get that similar finish, right? All the joints, details, whatever is there, we detail it out. We sit with the architects, we make sure. Only I know what the differences are, but a layman would not feel the difference, right? We made even the sample flat using the same precast systems so that they get to see the feel of the technology. This is one of the finished flats from interior, right? Once it's finished, even our own engineers would not know where the joints are. That's that kind of attention to detailing is done to make it finished. Now towards the technology. If you see any global, where I worked 10 years in US, and first class fine factories, all enclosed sheds, everything. Even there were air conditioned factories in a couple of locations. Compared to that, you are going to see this is my Bangalore factory, right? It is open. There is always the cost pressure is there. The way our infrastructure is, we cannot afford to transport these panels from a centralized factory for that volume. We don't have that kind of road network. We don't have that kind of bandwidth where I can ship 150 elements every day. So what we do is we set up the factory at the site. This is a temporary factory. Project is 4 years. At the end of 4 years, we wrap up that factory. We don't even use it for the new project, or at least that's how the philosophy was earlier. So that's how you will see very minimalistic factory. Bangalore, it does not rain like it in Mumbai, right? Mumbai, yes, it was raining until January last year. So I don't need the shade. I will save on that. But except the shade, all other quality measures, quality control, what we are operating are exactly similar to what you use in a control factory environment. Right? That's the philosophy. This picture, if you see, it is not taken on a Sunday, right? It is taken on a work day, full work going on. There is a gang working here. If this is a conventional construction, on this floor, you are going to see an army of people walking around, a barrage of material landing. There is safety screens. There is whole 9 yards going on. More activities, more material, more risk, higher chance of doing safety issues. Here, 10-15 gangs, it works. They know what to do every day. They will keep doing that and finish it faster. This picture, if you see a number of cranes, right? It is in my control. If I want to put up an extra crane, I can quickly do that, increase the output. The factory is already sized for that. If I want to slow it down, I will take it down. So that way we can have a better control. Erection activities are fairly straightforward, right? You get cleaner. There are connection dowels. They know what to do. make sure that the line and length is there. Panel is already ready, flat and in good to go shape. If you come to the factory, again, that controlled environment is the QA/QC working on the ground. They know what to do. Metal molds versus aluminum molds. It's two different systems, right? They stay flat. We don't have to work a lot on it. Daily cleaning, reinforcement control, where the tolerances are, cover zones are there, much easier to control. All your embeds and everything getting checked at every day. Usually, if you see, electrical embeds are concealed. MEP pipes and all we do undersunk, preferably. If not, we can do the conventional sunk also. But what we do for pipes usually is we leave the chases so that there is some access, because conduits you don't need that. Pipes, no matter what you do, there are joints, they may leak, so we leave that so that you can't jackhammer an M50 concrete, so we leave that and patch it back and work that out. So this is how the chases are made in the panel so that they're shipped out. Transportation, because my factory is right at the site, I don't have to worry a lot about it. We have now standardized norms, the A-frame, V-frame, trailer loads, and a very well established system to do the transportation. Again, comes back to site. There are very set guidelines established. They know what to measure. They know what to do the leveling. We have the push-pull props to make the levels after it's erected. Once they do that, everything automatically is going to fit in its place. Yeah, I think some of the same pictures again at the larger scale. But yeah, this is how that project, I think the architect had conceived the project in 2014, and this is how we finished it and handed it over in 2017-18 time. So that's that. One other thing in residential now that we are exploring, that I don't have to do the entire building, right? Again, I am catering to my site's demands, what they want in terms of speed and finishing. So if you look at a typical residential unit and you ask your construction manager saying, what are your biggest issues after the building is done, right? If you see 15 years ago, we were doing a typical building about 8-9 months, maybe 10 months, and then we are finishing about 6 months. Now suddenly we have brought these new technologies, and instead of 10 months, 11 months, I am finishing that in 6 months, but finishing is still 6 months, right? So now finishing is under pressure. So then if you ask him, he'll say that living room, bedrooms, I don't care, but my kitchens and my toilets takes the most time because most activities are there. And then it's a very smaller space usually. So I cannot have 3 agencies working at the same time. It's one by one. So then we said what we will do is we will look at finishing those in the factory. So what you see in the picture is a 10-ton element, which is finished. These photos are the finished photos of the inside of this unit. So everything was done in factory, finishing, waterproofing, coordination, everything done in the factory. And then the pod just kept before the slab is to be poured. Excuse me. And then we did the construction. When everything was finished, they came back and they only replaced the door because it needed protection. So they replaced the door and everything inside is ready. So this is the factory. This is the factory right at next to the tower, right? Because this was an experimental smaller thing. But the way we planned is that it was picked up right from here using the tower crane. So you are casting it here, all indigenous molds here. You cast it, you put it in the factory, finish it, lift it up directly and put it at the site. This is a typical mold, right? Again, this is not child labor. This is my son. I took him on a Sunday to visit it, and he was so excited about this. He's still talking about it a year down the line, saying those were the finished bathrooms, right? This is how we want the probably younger generation excited about the technology. He still talks about it and thinking, why can't we put finished rooms? And I think hopefully probably in a couple of years we'll do that too. So with that, now we come to our quality control, what we are doing in quality control. And for precast, usually quality control means how are you controlling your leakage, right? I'm going to be very upfront about it. And this is how we are controlling the leakages, right? Are we the first ones? No. If you see the picture, this was a building built in Mumbai in 1972. That's about 50 years now. I think the slide says 43. It's an older slide, but it's about 50 years now. Shirish Patel and Associate built this building, right? Up until 2016, we used to roam around saying we have built the tallest building, which is ground plus 23 story, and then we came across this building. Since then, we've stopped that, right? Total precast building, Each flat is probably upwards of 15-20 crores now. People are living in it. Building is functioning. They have maintenance issues. They have issues where some joints are leaking, this, that. But building is occupied. They are doing it. The owners don't have any significant complaints about it, right? So this is where that durability, this is where the joints, there is a live example in front of us. This is how we have evolved in terms of joints over the year. This is our Mumbai building, the ground plus 23-story building that I showed, some of the initial floors. And what we had done, because it was the first building then, and this was one of the biggest flat elevation which will get more or the most of the rain, we said we will just physically cover it, right? So if you look at this joint, what we have done there in that picture is there is literally a physical band which covers the joint, so water cannot go up. But some architects like it, some don't, right? Most after the buildings were finished, most people were thinking that as an architectural treatment, but it was really done to hide the joints. From erection standpoint also, if you see that panel swings and all, lot of times they get damaged. We don't have that kind of control, so our guys also don't like it. So what we did next job is we built that inside the panel. So we stepped it up, and the Provident Bangalore job, we have done that inside. So outside it looks flat, but inside this detailing is there. This is where again, if you're looking at competition, maybe improving the technology, this is where everything lies, is making sure your joint is covered and controlled. So there is a step, there is a non-shrink, non-metallic high strength grout, there is an additional waterproofing that we are doing everywhere, right? The philosophy is water should not go from one room to another as well. Forget the flat. So all rooms we are treating that, making sure that it doesn't go. And after we treat it, we make sure that actually they behave like a water tank. We are literally building water tanks now. So we flood the flats and we actually pond water and make sure that after 4 hours is taken out. But how the lower flats are doing, right? How are we seeing the leakages and all? And do we not get any leakage? We do, because it is not a water tank, right? We're trying to build it, but it's a residential unit. So there are area spots, some areas where we get the seepages. But from 2012 to 2022 now, if I have to put my experience, I a lot of times call structural engineer, forget it, I'm a waterproofing engineer. But if I had a leakage problem in 2012-14 time frame, today I have only a seepage problem, right? There is a big difference. Leakage is where you used to see drops. Right now what we see, whatever detailing we're doing, we see some seepage spots which dries also, we have to treat those, right? I don't have dripping water issues. There is no water, there is only moisture. That's where we stand today, right? Then for the external drain also, we are actually looking at actual sprinkler test. If you see, there are codes now which are specifying what the water discharge rate should be, how we simulate the rain. We have adopted this at that time using Singapore detailing, but now it is in IS codes also. So all that is looked at, and then we are scoring our own buildings. That's how the quality control or quality benchmark we are establishing for precast buildings. If you are familiar with Singapore system, there is CONCOS, we call it precast building quality assurance system, so PBQAS. But the Provident building we scored, we have our own set of data now, which I know each of building what the score it has, right? It's not 100 everywhere, some has 84, some has, that score has structural, architectural, all those details are there. But as a client, if you want to walk that Provident building, you're going to go there. I'm going to show you that this is the finished flat. This has the score of 84. When I build your building, I'm going to give you score of 84 or more. Earlier, we did not have that kind of database. Now I have my benchmark set. You will get the building better than Provident. How we'll track it is in terms of the scoring, right? So that's how we are doing it. Now coming to the last part of the presentation quickly is our ongoing work, right? This Sidco housing project, what we are doing differently. Like I said, we are right in the inception of it. So maybe next time we do a better focused presentation on just the Sidco job. But if looking at the value, this is one plot where we are doing now about 7,500 units, about 1,500 crore more. Total project, and about 66 buildings. We are doing about 25 currently. But when you look at that speed area, this is how is the plan, or this is what we had planned in terms of our delivery. So we are planned for about 30 floors per month. When the project peaks, every month, including all my cranes, I will be building 30 floors That means 1 floor per day. That translates to about eight flats per day. That's the speed we are talking about. How we'll build it is I have about 1.2 lakh elements, concrete elements. Each element is about 4 ton or so, except the slab, and we'll be producing in the factory, shipping it to the site and erecting. So imagine coordination of about 1 lakh elements plus. These are some of the photos of the overall one plot that we'll be doing. There is another plot, then there is another scope somewhere else also. So these are the towers that we will be building. This work is ongoing now. Now this comes to social housing, right? Mass housing. This is CIDCO for PMAY scheme, but the architect is architect Hafiz contractor. And on day one, they were very clear saying, I don't want my like bland buildings, right? They have their own brand. I want my signature on that building. So we worked with them, sat with them, all the reveals, all the bands, whatever that they had envisioned. Some of them were distributed so that I can make sure that the panels can be produced in the factory. But this was the elevations that were planned using precast, right? When people say that it has to have a similarity, modularity, the bands are still there. I am still shifting the bands. We are doing that enough work. I am giving whatever is needed at the bottom, at the top floors, and then still making this work using precast. This is our factory now, that Mumbai factory. Like I said, Mumbai trains, so I cannot afford to have an open factory. So about 11,000 square meter factory, about capacity of about 2.2 million square feet of built up area per year will be producing using this factory. If you want something relatable, about 180 panels per day is the capacity. At peak, we will be producing somewhere around 150 to 170 wall panels per day, right? Each, like I said, that each flat is about 15, 16 elements. So we are doing 10, 12 flats per day production in that factory. What we take pride in, most of these molds, whatever 3D, now we said we are moving towards PPVC. So we built 3D molds only for the bathrooms, but everything is built in India. So that what, of course, we have some molds that are coming from outside, but all these newer things we make it indigenously, so we have better control. If this wall you see, we are experimenting where the wall, the putty is done at factory. So even I don't have to take that activity at site. Whatever that I can do at factory, I want to do it at factory, finish it, do that activity, keep the panel ready. On the day of erection, send it, erect it, and forget it. Right, this is the one of probably about 2 months old picture of that all plots going forward. But whatever you see in this entire plot, I have 5 tower cranes, right? 1, 2 here, 3 here, 4th here, and 5th, right? Work is going on. So what you see is about 8 to 9 months when the picture was taken, and there is a 2.5 months for COVID wave 2 inbuilt here. So whatever you see is literally using 6 to 7 months that is built in front of our eyes. So these are those finished buildings. Again, this is, we'll get finishing, it will get painting, everything. Maybe a couple of months we'll have finished pictures also. But like I said, this building, if you avoid the COVID delays, this has been made there on about 6 months. This is our first building. This has been standing for about 6 months. So now come back to the last portion of the presentation, and we are looking at that 1.2 lakh elements count, right? I told you maybe 180 elements shipped every day, erected every day. So if I have to track that project, my usual Excel day-to-day tracking is just not going to be enough, right? I can't track that kind. It has to have some kind of automation. So we said we are going to build that digital solutions in place, right? Again, this is the need of the project. I'm not forcing the digital solution. I have to do it. I don't have any other way. So we took anyway the tender required BIM. So everything was done in BIM. That BIM was a central resource for all these agencies. Right? This is what day-to-day coordination is needed. I sit in BU, I review that. Client is looking at that. Design team is looking at that. Factory wants it. Site wants it. Planning wants it. So we started with the BIM model. And all these drawings, everything is done in BIM. So whatever you see in this picture, this is built in the BIM, including each rebar, each tie, whatever detailing, whatever accessories I have, the connection accessories, everything is in BIM. So once that model is done, this entire drawing is just at the click of button, maybe another 15% of work for some dimensions, this, that, but drawing is ready. Tomorrow I change this window size, that drawing is ready. That's where that BIM advantage we are specifically taking for precast. All my 2D shop drawings are prepared directly from BIM. Now, once I have that, we built our own in-house app which will track all these elements. So that was my idea, right? To do each element should have tracking. So this is still work. We are probably going full-fledged in usage by next year. I mean this year March. But what that app is doing at each element through its life cycle is being tracked. So when it was cast, with using what concrete, when it was demolded, what was the strength at that time, who checked it, when it was sitting in the yard, who looked at the pre-delivery inspection, when it was picked up, sent at site. If you click that barcode, or we have the QR scan, it can be scanned by any phone. Once I click at any stage, yard or site, if I scan it, it's going to give me the entire history of that panel. That's how we are tracking these elements and real time. So imagine earlier it used to be where panels were erected maybe a day before, then somebody comes next day morning, they put it in Excel saying these panels are there which were erected. Then by maybe next day afternoon, he's circulating the report. And somebody is looking at that and saying, oh, this is not right. Then it flags it. By the time site knows about it, 2 days are gone. Here, the 8 p.m. panel scanned, erected. I get that in the portal saying this panel shifts from this area to this area, saying the status is updated real time live. So that entire snapshot of the project I am seeing, I'm going to see it real time. How many panels are to be produced, how many are produced, how many are sitting, how many are shipped, how many are finished, right? Overall tower progress also we get to see that each floor wise in percentage of elements, how many are done, and once all done means my floor is done. So all these towers running, we will get to see this real time, and that way we can track it. Now with that, I know I've bored you guys enough, but last 5 minutes and then we'll wrap it up, open it for questions, is where we feel we need to go, or where maybe the technology would go. Like the structural portion, the design philosophy, the waterproofing, jointing, we have done enough. We have enough confidence, at least for the L&T product, that we can establish. And so where will we go? This is from my past life, right? When I used to work US, these are the projects that we were working. These are the projects that I have built. And I just want to put it out there saying this can be done in precast, right? If you see this, what is the unique thing about it is all this is a real brick cast into the precast panel and put it. It became very popular for the architect and all, finish and all. But what I see as a contractor, that there was no scaffolding done, there was no painting done. This is white cement panel concrete. It has its architectural treatment already. They just installed the panel. All they did is treat this joint with sealant and finish it. There is no outside activity to build this elevation. Same way, there is no outside activity to build this elevation. If anybody says that precast needs modularity, repetition, this full entire condo and a parking structure behind it is being total precast with all these varieties, different balconies, different elements, different projections. Everything is 100% precast. Whether we need this in India, we may not, right? This is a mixed use development, very low rise building, very unique demand. People are there who are willing to pay premium to build this. This doesn't come cheap, but it can be done. Whether you want it, whether our clients want it, is up to our engineering company, right? This is what that cast in brick feel is, but it's only a quarter-inch thick, which is maybe about 6 mm thin brick, what they call it. Now talk about that value creation. If you see this wall, it's combination of architectural treatment, a structural wall, and your entire facade. Sometimes they put insulation also behind it, so it works as a thermal wall. This is where 3 different systems have come into one precast system. That's where that advantage is. This is a brick facade. There is a steel bridge behind it, but all that minor detailing, architectural detailing, including the name and everything, was done at factory and just attached at site. This was done with the traffic going under it. Imagine that the cranes were operated from the sides, and that's why they did precast, is they didn't want to close the road. So steel was erected similar fashion, and then it was cladded with precast. This is a hotel building. All this gray cement, white cement, no painting. This came from the factory with the windows installed. They just attached to the core and finished the building. Same total precast office building. Same way, all exterior facade, 2 different tone panels, grooves, cornices, everything is done at factory. There are double T's inside. This is a school building. Some finishes, different reveals, grooves, your mesh green patterns. But the whole point to drive is they don't have people who can do scaffolding and do work from outside. So they want to finish everything in factory. We don't have to copy that. We don't have to mimic it, but we have to have that philosophy where our industry also is moving now, is to take it offsite, finish it offsite, build and erect it. This is some of the things where this is like a niche product, but if you want to get into graphics concrete or something, these options are easily available in precast, which can be done there. So with that, I thank you all. I know I bugged you enough with precast, but we'll open it to questions. If not today, feel free to approach us anytime. If you have anything relevant that we can look at it, we would love to work together with you. And then, like I said in the beginning also, I am really looking forward to that entries coming and reviewing the projects. So with that, I think Deepal will just quickly run that poll number 2. It just has one question, and then we'll open it for questions. Thank you all.
Yeah, thank you, Deepal, for the polling. I would now request Mr. S.V. Patil to kindly come online and begin the Q&A session.
Yeah. So thanks, Amit, and what an amazing presentation. And to sum it, I think it's almost like we went to the handbook of precast technology. Started with the conventional technology, the comparison between the conventional and the precast, the labor challenges, the maintenance challenges. Then switched on to what is appropriate for my, the current condition. And hybrid systems, rebalancing in design, depending upon the architect's requirement. And I think one of the important points that you addressed is how do we make it as robust as an in situ construction by emulative approach. This is also for the first time I have heard about this. I think with truly an example of getting it tested, almost matching the specific requirements of the in situ construction. I think a very innovation on pod construction for finishing of some of the elements like water closets, bathrooms, and maybe I think over a period of time we'll also come out with the kitchens as well. BIM is a very known technology, but I think what has taken to the next level of adoption is an app. So I think it is a wonderful journey from the day I think Precast has started, and as it is, you and L&T are setting the benchmarks in Precast, and I'm sure a lot of others will learn from it. And more so from the audience perspective, I think this has given the entire spectrum of evolution of not only the technology, but I think adoption to the Indian conditions, which is very, very relevant. Your experiences and how you improve over a period of time, both with respect to design, with respect to execution, the economy in the entire construction. I think it's not be surprising. The next time when you buy a flat, you must ask the builder, is it precast? And I'm sure with the amazing structure being built by precast, by people like Amit, it's going to change the entire quality and the speed and the expectation of end users like us. Thank you so much, Amit. And I think it was a great presentation. It could not have been, with so much of data packed in a very small time frame of 1 hour. You've done a fantastic job, I'm sure, for all our audience to get, I would rather say, a 360-degree view on precast, just not the technology, but how it is getting converted to the field. Phenomenally, I really personally enjoyed the entire journey, and I only wish we would have some more time to get into the details of some of your slides. Thank you so much for a wonderful journey through the precast construction.
Thank you. Appreciate it.
Raishton.
Yes, Mr. Patel, if we can start the Q&A session and you can put forward some of the questions from the audience and then we can have Mr. Amit Burde reply to those questions.
Yeah. So I just want to start, Amit, I think you did address one of the challenges most of the precast, I think you did address on that, on the durability of joints. And I think over a period of time, you're trying to modify, like I saw how the joints are getting covered, even the design aspects, and a combination of external treatment and internal treatment to address that. But assuming if this seepage occur over a longer period of time, so what is the kind of suggestion that we have for rehabilitation measures? Because I think conventional rehabilitation measure versus the rehabilitation measures for a is something different. So what do you think the right way to treat them? Because we can't have a same method for treatment of joints with respect to precast. Your view,
right? Okay. So yeah, like I said, even in my presentation, I said that it's not like we are getting that water tank type behavior for the detailing that we have. Believe it or not, this CIDCO job, we are building the water tanks, the overhead water tanks also using precast, but there is an extremely different detailing. So here, my focus is on using conventional precast joints, and there is a percent of joints we see seepages and all, and there are ways where we use a lot of times this pressure grouting ways. If not, there are specific mortars, there are specific with the crystalline product that we treat the cracks. Some of the cracks we have to treat, some we don't. So what we have done actually over the period now is we have actually it will probably sound very contradictory to what we want, but we have a standardized way for repairs. And we call it standardized, but there are standardized repairs for precast. That's the L&T way to repair the precast joints. So we have over the time surveyed the data. We know usually where the issues are based on our detailing, upside detailing. It depends on detailing to detailing. But that repair ways, which it will define that, okay, there are cracks, there are spalls. We have identified that, okay, anything that is more than 0.3 millimeter in width that needs engineering attention. If it's smaller than that, you just follow the standard way and finish it, right? You are going to see cracks in precast panels. It's a concrete product, it cracks. You handle it and all, hairline cracks and all, you cannot avoid it no matter what you do. But how to treat the cracks, which crack to treat it? In the slabs, a lot of times we see underside crack, but the slab gets a topping screed. So once that is done, then I'm not worried about those cracks as long as they are repaired aesthetically. So we have detailed guides now to do for each area identified, including cracks to your spalls, to connections, to leakages, and a detailed process, including the products to use or equivalent, and how to fix those. And yeah, if you are there, any precast manufacturer is there, their factory should have these kind of guides, because it will depend on your own experience, right? You cannot just take L&T's guide and use it. Detailings are different, ways are different, so you have to have your own set of documents for that.
Absolutely, thank you. And second one is you talked about precast and you talked about industrialization or industrial construction. So, so how do you think? What are the differences? And going forward, what will emerge for a country like India, where you are able to see better infrastructure, better automation, better handling capability? So do you think that it will migrate from a precast to an industrialized construction technology?
Yeah. So I would love to see it. I think, and probably a lot before I retire, where we have centralized factories for residential buildings, and we are churning out elements like piece of hot cake, like they say, and we are shipping it maybe 100, 200 kilometers away in a residential building. These factories are already there for commercial buildings, right? Believe me, there are plenty of manufacturers who have started. Some we've been operating for last 10 years also. So that is a different industry, but residential is a very different ball game. And that standardization, the commercial, they can operate it because to certain extent they can standardize it, right? If you see my US factory where I worked for, they had 15 defined elements. They say they will give you these 4 column sizes, these 3 beam sizes, these 4 slab sizes. You do that, those and fit it. That we are not there in residential, right? Each project floor cycle, my formwork sets don't repeat. They have to do at least 40-50% refurbishment for the next project. So maybe this is where the design or the architectural planning will come into picture, where we do some sort of standardization. I know it is difficult, right? You have, each state has its own requirements. There is vastu, there are 10 other things, but that is the market. So maybe over the time, if it evolves, that's how the true industrialization will happen for residential construction. That's how we will start seeing a centralized factory. Until then, this is why we took that call that we will have project specific factory. It's a lot of effort to set up a new factory just for 4 years, right? Most factories are set up for 20 years time frame. We are sizing that for 4 years and then wrapping it up. So if that evolves, we would be at a much better place.
Great. There is a very interesting question. Do you have specialized IS codes for precast technology?
Yeah, I think this one thing I would really like to thank Bureau of Indian Standards. I think Mr. Pant, who's actively been helping, supporting the overall technology itself. So earlier we did not, we had codes long ago also. If you look at that 11447, that's a 1980s code which talks about precast large panel construction. Maybe that time it was interest and they started that. But then it kind of over the time has not been updated. But last 4 or 5 years, BIS has been supportive, extremely supportive. We have now that IS 15916, which was one of the flagship code for last 2-3 years. It was now revised to 2020. Whatever I show, the rainfall simulation and requirements, things like that are now adopted as part of that code. And there are now sustained efforts underway also, where they will keep updating these codes. Maybe as we go further, there'll be more and more developments in precast specific IS codes.
Yeah, thank you. There is something, today we're all talking about sustainability on every industrialization projects, or even including the mobility that we are already looking for. So how do you think precast to help achieve the sustainability in the construction?
Sure. I think this we are getting this question more and more every day. If you look at even L&T now, that sustainable ways and green construction is on the forefront, maybe going forward next 6-7 years. If you see government housing also, there is now IGBC is there. There is that Gruha requirement, that there are talks that for housing they will be made mandatory. And then the construction industry, residential especially, the way we looked at thermal performance and all will drastically change, right? Currently where we stand, all these things seem maybe next 3-4 years and in the works. But where I see as a precast benefit is mainly 2 areas now. One, if you see, we don't use any curing at site, right? So all that water wastage, this is the intangible benefit, right? Nobody knows how much water is being wasted for curing. There is no track, there is no way to track also. But here what I do is, let's say if my building is G+14, let's say 12 to 14 story, my M30 concrete is going to be more than enough for design requirement. But if I have to put it in the factory and demold it the next day, I need at least M50 grade. I need at least M15 to M16 grade in 18 hours. So at that high performance concrete, by the time the concrete panel leaves the factory, it has gained more than M30. So we cure only in the factory in that controlled environment. We make sure that the history is tracked well, and I don't need any side curing. None of these except that grouting and joints what we are doing, and the skid concrete. We are not doing any side curing. So this is one of the biggest advantage in terms of sustainability, maybe the credits and all. The other is, of course, wastage is much less, right? Whatever we are doing at site, it is a control calculated. Each panel, what you say, the BIM model I showed you, I know exactly each panel how much cubic meter of concrete is needed. That much only is batched, that much only is put in the panel. Wastage is reduced. Wastage of steel also usually we are reducing, right? So if you look at it, at my site, if I'm considering 5% wastage, for precast factory is hardly 2% wastage. That's kind of control we have. So that is one where we'll have the sustainable way, and of course then using the local materials and all other benefits are there, which usually the IGBC or USGBC criteria are. So these two are probably where we are looking at the best compared to conventional construction.
Yeah, absolutely. I think even in addition, if you see, we all see almost in the winter time, there is a ban of construction in Delhi NCR because of the pollution. So since this is a factory construction, relatively you are reducing to a great extent pollution on site. So I think that is also adding to the sustainability of reducing the pollution level in the overall construction site, because other than the foundation is, just assembly. There is nothing beyond that. I very, very relevant points on that. There is something very, very interesting, and I thought I must ask this question. So one of the audiences asked that it requires less labor, and on the other side, we are actually looking at labor employment. So do you think that it is contradictory to the, on one side we are talking about engaging the labor, on the other side we are talking about reducing the labor. Is it contradicting with respect to the objective of providing an employment versus promotion of new technology?
Sure thing. I think I would probably answer this question the other way, that if that workforce was there, I would not have done precast at all. Like I said, we are doing precast because we don't find people. If that earlier that whatever norm was there when I started working in the precast industry in US, I had a feeling saying this will never work in India because we have so much workforce is there. Why would I need to produce in factory? You just put 10 more people and get it done. That situation is not there anymore. Even if I want to, I don't find people who know what to do and do that. So we are kind of answering that lack of workforce using these technologies. I don't think we are taking anybody. If there are people, I would still, there are a lot of challenges setting up the factory, doing these things and all, I would do that. But I don't think there is any, unless somebody wants to get skilled and all, but that is not there. Believe it or not, L&T has 8 centers across India who will train people to do construction activities, right? Not just precast, any construction activities. They get the hostel stay, food stay for 8 months. They get a certificate at the end of the course saying you are qualified construction worker. They don't even have to work in L&T. They can go and work anywhere. And those programs are still not running there. So this is where we are, right? So that's what we are addressing. I don't think we are reducing any workforce or creating any issues for people. Second, if I'm using 15 people at site, I'm still using 300 people at the factory that they are employed and they are not leaving. There is a huge retention, higher retention rate at the factory. They like working. Sometimes they are willing to work at a lower rate for the same work. Let's say reinforcement bending. They are willing to work at a lower rate than what they will work at site, but they are working in shade, nice area on ground. They know every day, and there is no relocation involved. That factory will go for 4 years. So all those benefits are there.
Absolutely. I think what really you are trying to do is upskill the laborers with the new technology.
Correct.
I think who doesn't know your training center, state of the art, with the certification course for and for the gentleman, panel member who has asked this question, feel free to connect with the L&T website and you will have key details about these centers. More and more candidates can be sent, and when they come out, they are highly skilled laborers for workforce. So request all the audience, whoever doesn't know about this, please percolate this information as much as possible. It is an excellent upskill center. And correct me, Amit, you just need a minimum educational qualification of around 10th or something, and you are home and right to join courses. Thank you so much for a great service being done apart from generating the employment. There is an interesting question which is technical, and I think you are the right person to answer. Generally, panel to panel joint on external side is done through sealants. Will there be a need for redoing sealants regularly, or as and when leakages occur? So, is there a regular maintenance schedule, or even when there is a leakage, then will you address these panels outside?
No, so I think once the sealant is put, there is usual maintenance in terms of visual observations every 6 months or a year that the industry has to now come up with a standardization. We don't have that. But if you see glass pasar industry, they're doing it. Every time you see sitting in your office when the window washing guy is cleaning it, at the same time he's looking at that sealant also. Visual inspection only, there is no other maintenance required. If you see any spots which are damaged or coming off, they just have to reseal those. So those same conditions apply here. uh, but now that we are talking about sealant, I think one of the biggest questions that comes for sealant is the life, right? Now somehow in Indian industry there is this expectation from RC building that 50 years life, right? It has come from the wind code saying return period, but that has become the norm. Everybody is looking at 50 years of life. And there is no sealant which will give you 50 years of life. The 50 years are in general building life. If you see all outside codes, here also India, some codes it's spelled out, but it is not standardized. Is 50 years is for non-replaceable items, and the sealant comes under the replaceable item. So this is what that visual maintenance, whatever is there, you have to take care of it. That nominal items have to be done. uh, Also sealant is not the only way, right? There are grouted joints, grouted connections. Where the outside industry mainly uses sealant is because they are not using this emulative detailing. They have moved away from wet joints where they use bolted welded connections, and their joints are actually moving. And because the joints move, they want this flexible sealants. In here what detailing we use, the joints are not moving as much at all. We have believe that the Bangalore building that I showed, that is without sealant. We have used just the grouted joints and grouted finish joint. There is no sealant in those buildings. So it depends. You have to take your call what you want out of your building, what is your maintenance schedule, who is going to look at it, and then decide what you want to do.
Yeah. So there are plenty of questions, Amit, which we will send it across to you. I'm sure you would love to answer most of them. But I would like to take the last one, which I still find very, very interesting one. Excellent presentation, intense research and innovation. Compliments to you, Amit. How do you see the precast technology from environmental perspective? And the more concrete means more cement and usage of natural resources. Overall, we are increasing the carbon dioxide that we breathe. So how do you look at this as an environmental friendly construction?
Yeah, right. So I would answer it this way, and this is altogether a different topic. But there is a next generation of now precast panels where we'll be using thermally insulated panels. I briefly mentioned that, which only the precast industry can effectively build those panels. Where assume a 160 thick wall, instead of putting 160 thick concrete, you are putting 50 inside concrete, 50 outside concrete, and there is an insulation board inside it. This gives me thermal performance. It reduces your electric consumption, energy consumption. One, this reduces your overall concrete consumption to begin with. That panel is still designed composite and it performs as a 160 thick panel, and it will reduce my element weight. It reduces my resources, my crane capacity, my truck capacity. I can send more panels in a truck than what I used to send. It actually solves all other issues. So there are ways around it. We just have to start using those ways. Make ourselves, I'll leave it to saying, let's keep our minds open, adopt this product, right? Adopt the technologies. It took me 10 years to get where we are now, where we are doing large projects, which I thought that, okay, I'm going to change the way Indian construction works and copy paste the outside way. Then in second year I'll be doing projects left, right, center. But it doesn't work that way in India. Of course we are going through those cycles. Maybe every developing nation goes through that cycle. So maybe the engineering community, the architectural community, or the owners, let's open up our ways if you want to get there. So if you want to make it environmental friendly, there are ways to do it. Why it works it in US? Because the government supports it, right? Nobody is doing gold and platinum certified building in LEED in US. They're doing it because government gives tax benefits. Otherwise everything is expensive to do in LEED certified products. So that kind of support, that kind of framework has to come. That one thing we have seen always, it has to be top driven. Singapore is doing entire their social housing in precast because the government mandated it. China is doing entire construction in Beijing and Shanghai in precast because government says nothing else, only precast 100%. So that larger scale always have to be driven by the top.
Absolutely, absolutely. And in this direction of environment friendly sustainability, what we are also from our side trying to do is we have already pushed the concrete optimization with 70% replacement of GBBS, 70% replacement. Right. We're able to get equivalent strength in most of the. So one way of looking at it, how do I reduce the carbon footprint in the concrete from the material side? Secondly, we are also piloted the EVA, which is substantially going to reduce the thickness of structure, improve the durability in the long term, and it is going to be so. From the material side, a lot of work being done, even to ensure that what you call as a carbon neutral concrete by 2050, and sure, even a part of the L&T journey, you are part of that particular journey. How do we make it, carbon neutral concrete by 2050? So thank you so much, Amit. There are barrage of questions, and I'm sure we will send it across to you. Would love to reply each one of them. Thanks, audience, for a excellent quality of questions. And the subject itself is so vast, and the questions will be unending. And I think every day when we look at the new type of precast, there will be questions, there will be answers. Thank you so much, Amit. Over to you, Rashmi.
Thank you.
Thank you, Mr. Patil, and thank you very much, Mr. Anil. I am still seeing the questions that are coming on the chat box. One question in particular that I want to state over here is an engineer who has written that thank you Ultratech for this session, and it was so great to have a speaker like Mr. Amit Burde, who was so detailed. I would love to have 20 more sessions from him in this month. Is there a way that can send us some kind of a link wherein we can watch his session at least 20 times in this month? So I think the audience has really loved the session and are wanting for more. I think this 45 minutes is very little time, but I think a lot of people have found it very, very innovative and very, very new. A lot of things have been expressed on the chat, which we will share with you, which states that our faculty, our community, our engineers are always looking for such expert sessions, and it's great to have you speak on this discussion and this topic. And I think it's very, very encouraging for a lot of people who are here to gain that knowledge. So thank you very much for coming, and I would also like to especially thank Mr. Patil for being the voice of the fraternity, for putting all the questions together. I know I could see the questions and everyone wants an answer. Hopefully we'll be able to do that. But thank you, Mr. Patil, for being a great moderator and facilitating this conversation between our audiences and our expert panel. I thank all our audiences for making time to attend the session. The webinar series has kept to its promise of exploring state-of-the-art construction technologies for rapid and cost-effective construction. It has been super buzzing evening, 1.5 or almost 2 hours, but very engaging. Very, very few times we have so many questions, and I think this time the chat box has been very, very engaging. Yeah. So for those whose questions have been unanswered, we get a lot of these on our post-event feedback. Don't worry, we will try and send those questions to Mr. Amit, who hopefully will remove some time and answer those questions, and then we will send those responses to you on your email address. We will have a session. A lot of people have asked us, can we get to see this recorded session? We missed it. We joined 1 hour late. But just for everyone's information, we will have this session. The session is being recorded. It will be put up on our website, on our web page, which is www.ultratechindianext.com in the next 72 hours. All of you can come visit the website. All the previous sessions have also been uploaded, and this session of Mr. Amit Burde will also be uploaded in case you have missed it. So thank you once again, Amit. Audience all of us would like to hear from you for, I hope not the last time, but for this session at least.
Appreciate it. Appreciate the, I think, opportunity. Like I said, looking forward more towards the the competition and going through it. And thank you very much. Enjoyed it.
Yeah.
Thanks a lot.
Thank you, Mr. Amit and Mr. Patil sir once again. Hope everyone this time online. Next time I hope we'll be able to do a hybrid, which is online and on ground. But hope all of you had an informative and constructive evening. Goodbye. Have a great weekend and let's build with speed. Bye bye, everybody.
Sure.
My pleasure.
Bye.
Thank
Have a
you.